Liquidations are actually a lot of code, so it's fairly difficult to adapt to it and to really understand them. But what I want to start with is a foundation of it. And I mentioned this in a different workshop, but the idea behind liquidations is that there is 4 possible states. And to really visualize these possible states, you want to look at these calculate partial liquidation, surplus, and cap function. And then you want to look at the alternative function called calculate full liquidation, surplus, and cap. And as you may have noticed already, I have some audit tags already in the code for you to kind of be warned. This is an example of an invariant that we actually want to assert in the code. So we can spend hours debating whether you want me to remove the assert, but this is an example of an actual assertion that we need to maintain so that Echidna approves that that's what's going on, because the hidden invariants of partial liquidations are multiple, and I'm gonna go over all of them. But before we get to that, let's talk about the basics of this idea here, which is basically clamping the dynamic premium. So this is an idea in general, and then I'm gonna go over both the partial and the full liquidation flow. But the idea in general for eBTC is that you will always get, at the very least, 3% bonus, so you basically get 1 of 3, plus the stipend. That's what you will always get. And then if the CDP is healthy enough, we're gonna give you a bonus that grows up to MCR, so up to 110 plus the stipend. And so that's really what we're doing here. When I say clamp, that's what we're doing. When we have these if else right here, that's what we're doing. We're capping the minimum. We're raising the minimum to 1 of 3, and we're capping the maximum to 110. Something very interesting to me about how we do this is that in the full liquidation, when we are under collateralized, we don't look at the system as the debt we burn over the price, but instead we look at the debt to repay as the collateral times price divided by the bonus. And so the reason why this happens is because there's more debt than collateral, so we're limited by the collateral. And for this reason, we kind of compute it the opposite way, where we're basically giving you discounted collateral that is burning only that amount of debt. That's really how you want to look at it for a full liquidation, and you want to look at it differently from a partial liquidation. So I said a lot of things, and now I'm gonna kind of start again. And let's start from the full liquidation. Let's look at each of these lines. You're gonna have a CDP. They're gonna have a specific internal collateralization ratio. They're gonna have a price, an amount of debt, and an amount of collateral. What's going to happen here is if we can afford to give you more than the minimum, so this is this liquidation will not create bad debt, then basically the collateral we're giving is effectively the amount of debt you burn multiplied by this dynamic multiplier, which is at most the MCR, so at most is 110, and at minimum the ICR, which will be something above 1.3, so we could call it 1.3 plus plus up to 110. And we're going to divide it by the price, and that's going to determine the collateral you receive for the debt that you are repaying. And then we just convert this into shares by looking at effectively the math. So something interesting that we do in the liquidation as well is that this call is not or rather incentive call, which is here. This is actually collateral amounts. It's not shares. So this is the edge of the math where we actually break our own convention of using shares all the time. And that's because our price feed is not expressed in shares. Our price feed is expressed in collateral. But I hopefully conveyed these 2 lines. And then down here, we simply have some validation to avoid sending too much, or to ensure that if there's nothing left, we basically compute it, or we just set it to 0. So that's really what's happening here. Is just the either a rounding error or extra amounts. And then the opposite scenario for the full liquidation is when we are underwater. And as we said, when we're underwater, we're going to look at everything we got here, which is here, total collateral to send, incentive call. That's everything we have. And we're going to effectively burn all of the collateral and use that to determine how much debt we're going to repay, because you're basically, you're effectively buying collateral at a 3% discount here, LICR being 103. So it's 1.03 E18. But ultimately, that's what's happening. And so due to that, we know some debt will be left, and that's the debt to redistribute. And lastly, we have the two liquidator equal to total collateral to send, where again, we want to cap it to avoid any weirdness. But ultimately, that's really what we're doing, is just two scenarios. Instead, in the scenario of a partial liquidation, again, we have all of these in collateral, not in shares. Again, if we have between 103 and 110, it's really simple. We just have the incentive collateral. We know this is a partial. We already validated the size of the liquidation in other functions. So we know this is going to not generate any bad debt, right? This is why we have this assertion. And I want you to challenge this, because maybe there is a ratio of collateral and debt that makes it so that we should have a redistribution of debt for the partial liquidation. But the current code does not. So that means that as long as you have the minimum collateral of 2 stETH plus the stipend left in the CDP, then it's a partial collateralization, and you could have 1 or 1 or even less of that, and this is not going to trigger a bad debt redistribution. All the bad debt is still going to be in the CDP. So, but this scenario will be the healthy one. This is a healthy liquidation with a premium. Same idea. We use the debt to determine the collateral, and we know it doesn't need to be capped. So that's why we skip the capping there. And then instead, if we are below that, we're going to use the similar logic where you're using the debt you're burning to effectively give you more collateral for less because of this calculation right here. Then we compute what we're going to send to the liquidator. We're going to verify that we're not going to leave nothing. So that's why this check is basically converted into an assertion. We ran it through Echidna Medusa for tens of millions of runs, but that's why it's an assert. And then lastly, we determine what the amount that is going to be left in the CP is going to be, and that's going to be verified to be above the minimum size.